Hi, and welcome on board to Flexcompute Flow360. We would like to thank you for trusting us with your simulation needs and look forward to helping you advance your ideas to reality. We're excited to have you on board and to get you running simulations as quickly as possible. Our team is here to support you whenever you need us, and we have comprehensive online documentation and technical support available at all times. With that, let's jump into part one of our training, the introduction. For today's introduction training, we'll cover 5 things. First, the training structure and a high-level outline of what is covered in each session. Second, an overview of the Flow360 solver. Third, the end-to-end workflow using Flow360. Fourth, useful resources to help you with your onboarding. And last but not least, where and how to get help. You can see an expanded visualization of the training structure here. In the next training, we will cover the web user interface, the third will cover the Python API, and then we will jump into more advanced topics. Now, starting with a quick solver overview. Flow360 is a GPU-native, fully compressible Navier-Stokes solver. It uses an unstructured, node-centered approach and supports mixed elements. It's a second-order finite volume solver, using an implicit dual time stepping scheme. For inviscid fluxes, it uses a row-Riemann solver with muscle extrapolation. Default settings are generally sufficient. You typically won't need to tweak solver parameters. Now covering key capabilities of Flow360. We support steady and unsteady cases, RANs, URANs, DDES, ILES, and ZDES, which is zonal DES. Turbulence models include standard SA and K omega SST, with QCR and rotation and curvature corrections available. For rotor modeling, we offer multiple options balancing fidelity and computational cost, including actuator disk, BET line, moving reference frame, and sliding interfaces. We also have an aeroacoustic solver, a load dissipation scheme to increase accuracy on transient simulations. We support user-defined dynamics, porous media, wall modeling, conjugate heat transfer, and an AFT transition model. Now we'll cover how to use these capabilities within the workflow. We offer a typical workflow from geometry import all the way to post-processing and visualization. There are multiple entry points available throughout the workflow, allowing you to start from a geometry, surface mesh, or volume mesh. We offer 2 methods to interface with the solver: a web UI, which provides a more interactive setup with immediate visual feedback, and a Python API, which allows you to automate through scripting and reuse for multiple cases. This slide provides a great overview of which method might be best for your use case. The web UI is great for quickly setting up a simulation and getting instant visual feedback. This does require manual point-and-click setup and inserting values. We recommend using this for your first time just to experience the web UI. Some other use cases include quick single-case runs or inspecting an individual case. The Python API is great for automation, integrating Flow360 within your existing workflows, and a clean interface. The only disadvantage is you will have no live visual feedback. Some common use cases for the Python API include setting up Arrow database sweeps or integrating the solver within an established pre- and post-processing workflow. In the future, we will have full web UI and Python API integration to allow you to do everything on the same platform, meaning automation will be available directly in the web UI via a scripting area, while still supporting Python. Now we'll jump into some more workflow details to become familiar with Flow360. Covering projects, this is how we organize different stages of a simulation, which provides an intuitive way to view, track, and navigate to different stages of your workflow. The project tree will have all stages, like the geometry, surface mesh, volume mesh, and different runs performed. This helps keep all data organized and allows you to reuse settings from one stage to another, for example, running a mesh refinement study or performing large parameter sweeps. For geometry import, we support face and edge grouping to allow you to select those groups during your mesh, setup, and post-processing. For volume mesh, we read all boundaries and volume zones. For units, we support dimensional units and support a variety of unit systems, including SI, Imperial, and CGS. You can mix units within the tool and everything will be converted. We also support non-dimensional units, but this will be discussed more in the Python training. For string inputs, you must use non-dimensional units. For geometry requirements, we support watertight BREP solid models. There can be multiple solids, but they all must be within a single file. Many different formats are accepted, and you can see the full list over on the right. If you have a format not listed here, please reach out to us, and we will ensure we can get it imported. We also have some best practices that we recommend for geometry. This includes avoiding pinch points and small gaps between surfaces. Your model should be well posed for meshing and be composed of solid bodies, not sheet bodies. We also offer access to a geometry tool for parametric design called Engineering Sketchpad, or ESP. This is a powerful tool to create geometry. It will create a watertight model and allow you to parameterize the model very easily. All that's needed is an analytical representation, like a shape or curve lines, and then you can generate a model. Using ESP is not required, but it is an additional option for geometry creation. ESP can also be used for preliminary checking to identify geometric issues at an early stage by importing a step file for analysis. Now moving into meshing, we'll cover some general meshing requirements. We support importing manually generated mesh, or offer a highly automated process that we'll cover in the next slide. For manual mesh generation, we support CGNS or U-grid formats. Multi-zone meshes are only supported with CGNS. Unstructured mixed elements are supported, but polyhedral elements are not. We do have a mesh decomposition tool to convert the polyhedral elements to tetrahedral elements, and if this is something of interest for you, please discuss with us. We don't have major restrictions on the mesh quality that must be satisfied for our solver, because it's very robust. The only important metric is the area ratio has to be lower than 20. If you are modeling rotating regions, they must be bodies of revolution. And mesh between multi-zones can be non-conformal, but conformal mesh results in improved accuracy. Now covering our automated meshing workflow. Flow360 offers an automated meshing process that reduces the amount of inputs required by providing default values that are sufficient to generate a high-quality mesh for most cases. The only inputs required are the surface max edge length and boundary layer first layer thickness. The rest of the defaults are sufficient. Advanced settings are available if necessary. We also have our own mesher that is currently in development that can be activated when starting a new project using the Beta Mesher flag option. This will be covered in the Web UI training session. Now wrapping up with beneficial resources to support you during your onboarding and training. We have our documentation, which is available online using the link shown here. This is continuously updated with new features and releases, tutorials, and more. It will also walk you through a quick start process from getting access to the Web UI or Python API, and then the complete workflow. Documentation is also available directly within the web UI. We have a separate section in the documentation that has all publications to help support you, including webinars, papers, and more. This is continuously updated with all new content as it is created. Finally, we have the Flow360 GitHub repo. This is useful if you are looking for a variety of example cases we have made publicly available. All scripts can be copied and reused for your own workflows. All material here is being moved over to the documentation link, but this repo remains a great starting point, especially for Python users. As you continue your onboarding and beyond, we are here to support you. Our documentation has a knowledge base section, we have tutorials available, and our team is always here to support you through meetings, email, or Slack, where you can also provide product feedback to help shape the development of Flow360. We look forward to working with you, and we would like to welcome and thank you again for choosing Flexcompute as your partner.